So we are looking at radian measure and angles on Cartesian plane. So now we are going to recall from grade 11. So how do we first of all place our angles in Cartesian plane? Okay. So we always start our angle from the positive x-axis. Okay, you start your angle from the positive x-axis. If you have a positive angle, you go counterclockwise. Okay, and then after the measurement, you put the terminal arm. So the first arm is called the arm that you put on the positive x-axis is called initial arm. Okay. Then you rotate the angle in counterclockwise direction, and then you place your terminal arm. Okay. But if you have a negative angle, so they are measured in clockwise direction. Let's say you need to measure negative 225. So again, you put your initial arm on the positive x-axis, but because it is negative angle, you go clockwise direction and then put the terminal arm. As you see, positive 135 and negative 225, thank you, have the same terminal arm. So we have a special name to call those angles. Again, you will remember it from grade 11. We call them coterminal angles. Coterminal angles. So coterminal angles have the same terminal arm. Okay. So coterminal angles have 360 degree in terms of degrees between them, right? You can add or subtract. Let's say you want to find coterminal angles to 30 degree. So what would you do? You would add or subtract multiples of 360 degree to get other coterminal angles. Let's say when you add 360, you get 390 degree. Okay? Or when you subtract 360, you get negative 330 degree. Or you could add 2 times 360, let's say 720. Or you could subtract 2 times 360. Okay, so just multiples of 360. So though all of these angles have the same terminal arm, right? Let's say if you have 30 degree, 390 is going to be here. So it also has this same terminal arm. Okay. Or if you have negative 330, so this time you start from again positive x-axis but go to clockwise direction, and it also has the same terminal arm. So these angles are not the same angles, but because they have the same terminal arm, they have the same trigonometric ratios, like sine ratio, cosine ratio, or tangent ratio of all those angles. And there are infinite number of coterminal angles, right, for the same angle. So they all have the same trigonometric ratios. Okay, so let's move on and look at principal and related acute angles. Again, this is a review from grade 11. The trigonometric ratios for any principal angle theta in standard position. Let me try to make it bigger. Okay. Principal theta. We usually use symbol theta for the principal angles. Okay. So trigonometric ratios for any principal angle theta in standard position can be determined by finding the related acute angle beta. And again, we use symbol beta for the related acute angle. So using coordinates of any point that lies on the terminal arm of the angle. Let's say, actually it is better if we work with an angle that is in the first quadrant. it's going to be more helpful here. Let's say you have theta in the first quadrant. Okay, this is your terminal arm. Let's say we have a point on the terminal arm, x and y. Okay, so if you drop a perpendicular line to x-axis, so you know that this distance is going to be x, and if you draw a perpendicular line to y-axis, so this distance is y. Okay, then using this triangle, and we can write sine ratio, cosine ratio, and tangent ratio in terms of x and y. Okay, so first of all, this is a right angle triangle. Okay, so one perpendicular side is x, one perpendicular side is y. So this hypotenuse, usually we use symbol r, and it comes from radius. This is how it goes. So if you rotate, why do we call it r? You put the initial arm on the x-axis, and when you are measuring, you are moving the terminal arm and stop after you measure the angle, right? How about if you rotate the terminal arm one full revolution? Okay, if you do it one full revolution, what do you get? You get a circle, just turning the terminal arm one full circle. Okay, so one full revolution. So therefore, if you do that, if you rotate the terminal arm one full revolution, you get a circle. Then that hypotenuse actually is same as the radius of that circle. Therefore, it is named as r. Most of the time you will see it as r. Using the Pythagoras, so what can we say about that r? It is x squared plus y squared. Okay, that's how we calculate it. Okay, now let's use SOHCAHTOA to find sine, cosine, and tangent. Sine, opposite over hypotenuse, opposite over hypotenuse, y over r. Cosine theta, adjacent over hypotenuse, x over r. Tangent, opposite over adjacent, y over x. So now we are also going to look at the reciprocal angles. Again, it is a reviewing from last year, so you already learned this. Cosecant theta is 1 over sine theta. Secant theta 1 over cosine theta. So those are called reciprocal ratios. And cotangent theta is 1 over tangent theta. Usually everyone remembers tangent and cotangent, they are reciprocal of each other. Some people get confused, oh, cosecant was reciprocal of sine or cosine. So this is how I usually remember. Okay, so look at the first letters of each. So sine theta and cosecant theta, right? So we said they are reciprocal of each other. So first letters are s and c, and if you compare cosine and secant, C and S. Okay, so they are kind of matched oppositely, right? So see, it is not cosine and cosecant, they both start with letter C, or we can't match sine and secant, right? They have the same, they start with the same letter, but they are not reciprocal of each other. So they have kind of, you know, opposite letters. If you you can remember it maybe that way. Okay. Oh, we didn't talk about the related acute angle. Related acute angle is the angle between the terminal arm and closest x-axis. Okay. Again, related acute angle is the angle between the terminal arm and closest x-axis. we already have this here, but okay, so let me sketch it here. Let's say if you have an angle in the first quadrant, okay, so that is theta. So that is your terminal arm. So if you draw the angle between the terminal arm, the closest x-axis, so we get this. So if your angle theta, which is a pure principal angle, in the first quadrant, then related acute angle and the theta both are the same, right? So beta equals theta. How about if we have an angle in quadrant 2? Okay, then this is your terminal arm. Then the angle between terminal arm and closest x-axis is here. Then this is beta. Okay, so beta is then, in terms of angles, 180 minus theta, correct? Or similarly, theta equals 180 minus beta. But don't forget, now we start working with radians. So 180 is same as pi. When you are working with radians, this time we are going to say beta equals pi minus theta, or theta equals pi minus beta. Okay. So you just replace 180 with pi. How about if you have an angle in quadrant 3? What happens then? So angle in quadrant 3, so that is theta. This is the terminal arm. So the angle between terminal arm and closest x-axis is here. So that is beta. Okay. Then what would you say about beta? Okay. So that is theta. If I subtract half a turn from theta, I would get the beta, correct? So theta minus 180, right? Theta minus 180 would give me, let's say theta is 200 degrees, then I would subtract 180 from it to get the beta. But now we are working with the, again, radians, so we say theta minus pi. Okay. Similarly, if you want to get theta, see, you need to have this half a circle, 180 degree plus the beta. That would give you theta. But now we are working with pi, so we can say theta equals pi plus beta. And if you are in the fourth quadrant, so that is your terminal arm, that's your theta. Then the beta would be, again, the angle between the terminal arm and the closest x-axis. So it would be here. Then what would you say about beta? If this was one complete revolution, that would be 360. But so to get the beta, we can do 360 degree minus the theta. Or in terms of radians, 2 pi, 180 is pi, 360 is 2 pi. So 2 pi minus theta. Okay. Or if you needed to calculate theta, you do 360 minus beta, or 2 pi minus beta. Okay. So let's look at the cast rule. Again, you learned this in grade 11. Okay. So there are 4 angles in this Cartesian plane that are in 360 degree, of course, that are related. Okay, and of course, if those angles, if they are not on the x or y axis, if they are not quadrantal angles, okay, so if they're on x axis or y axis, so that is another story. But if they are you know, anywhere else, so there are 4 angles that are related. So what do we mean with that? Let's say we have 30 degree, okay, so 4 angles that are related are 30 degree, 150 degree, 210 degree, and 330 degree. Okay, so these are the terminal arms of those angles. What is common between them? Their related acute angle is the same. So the angle between their terminal arm and the closest x-axis is the same. So these are all beta. Okay, and they form a bow tie, and those 4 angles are related because they have the same number, but 2 of them are positive, 2 of them are negative. Let's look at their sign. Okay, so sine 30 is 1 over 2. Sine 150 is 1 over 2. Sine negative 1 over 2, and sine 330 is negative 1 over 2. Okay, as you see, all these 4 angles have the same number as a ratio, but 2 of them are positive, 2 of them are negative. Okay, so therefore we call them related angles, and because they have the same related acute angle. Okay, they are related. So let's look at now cast. So how do we know then, you know, let's say we are working with those angles, how do we know which ones are going to be positive, which ones are going to be negative? So we use cast, okay, to know, okay, which ratios are positive and which ratios are negative. So here, you know, quadrant 1, 2, 3, 4. So you start writing cast from quadrant 4. Okay, cast, and this is what it means. In quadrant 1, A stands for all trigonometric ratios are positive. Those letters are telling you which ratios are positive in which quadrant. Okay, in quadrant 2, only sine is positive. In quadrant 3, only tangent is positive, and in quadrant 4, only cosine is positive. Okay. And we already talked about this bow tie method. We talked it. Here. We just did that. Okay, now moving on. Okay, on the next page. Now we are going to look at the definition of sine theta, cosine theta, and tangent theta in unit circle. So what does unit circle mean? Any circle with a radius of 1 is called unit circle. Okay, so if you have a unit circle, let's say you have angle theta in the first quadrant. Okay, so this is the terminal arm. So and if you take a point on that terminal arm, let's say point P, okay, and coordinates we don't know, let's call them x and y coordinates. Okay, so because it is a unit circle, so the radius is 1, right? Then using this triangle here, okay, so first of all, again, if the coordinates of that point is x and y, I can draw perpendicular line to the x-axis and then perpendicular line to the y-axis here, and we know that this side of the triangle will be x, this side of the triangle will be y, okay, and radius is 1. Now we can again use SOHCAHTOA to write sine ratio, cosine ratio. Sine ratio, sine theta, opposite over hypotenuse, y over 1 gives you y. So basically sine theta equals y, or y equals sine theta. If you write cosine theta, adjacent over hypotenuse, x over 1, so gives you x. So cosine theta is same as x, or x equals cosine theta. Tangent theta, opposite over adjacent, y over x. We just said that y is sine theta and x is cos theta. So tangent theta is same as sine theta over cos theta then. This is one of the, most used identity. Tangent theta equals sine theta over cos theta. Then what can we say? We just said that cos theta, so x coordinate, x is cos theta and y is sine theta, okay? So then if you have a unit circle, you can look at the coordinates of any point taken on the terminal arm, right? You can take any point, and the x coordinate will give you the cos ratio of that angle, and the y coordinate is gonna give you the sine ratio of that angle. So we usually use this unit circle to determine the ratios of quadrantal angles, okay? That's the most used part. So let me draw unit circle here. So if it is a unit circle, radius is 1. If radius is 1, the coordinates of this point would be 1 and 0. Coordinates of that point would be 0 and 1. This point would be negative 1 and 0. And this point 0 and negative 1. Okay, I just draw any unit circle with radius 1. So based on that, now we are going to look at these ratios. The first one says sine pi over 2. Pi over 2, again let's remember how many degrees? So pi is 180, pi over 2 is 90 degree, right? So we are here. So that is your 9th pi over 2. Okay, so this is the terminal arm of pi over 2. What is the coordinate of this? 0 and 1. So with the previous explanation, we said that if it's a unit circle, first coordinate gives you cos, second coordinate gives you sine. So this is cos and that is sine. So cosine pi over 2 then is 1. Just looking at the coordinates of this. Cos pi over 2, so you check the x coordinate, which is 0. Tangent pi over 2, so y coordinate over x coordinate, or sine over cosine. So you get 1 over 0. 1 over 0 is undefined. Okay, sine pi. So now we are here. This is pi. Okay, so terminal of arm of pi is here. So we are gonna use then these coordinates. Again, first coordinate will give you cos, second coordinate will give you sine. So sine pi 0, cosine pi negative 1, tangent pi sine over cosine, or y over x gives you 0. Now we are doing sine 3 pi over 2. So pi over 2 is 90. 2 pi over 2, which is pi, 180. 3 pi over 2, 270. Okay, so 270. We are here. So first coordinate cos, second coordinate is sine. So sine 3 pi over 2, negative 1. Cosine 3 pi over 2, 0. Tangent 3 pi over 2, negative 1 over 0. So undefined. Now sine 2 pi. 2 pi is 360 degree. So we are here. So terminal arm is right this one. So 0 degree and 360 degree and all multiples of 360. So terminal arm is right here on top of the initial arm. Okay, so again, first coordinate gives you cos, second coordinate gives you sine. Sine 2 pi, you get 0. Cosine 2 pi, you get 1. Tangent 2 pi, sine over cosine or y over x gives you 0. Okay, now we are going to remember special angles. Okay, so last year in grade 11 you learned these special angles and special triangles in terms of degrees. So 45 degree, 30 degree and 60 degree are special angles. Okay, so 45 degree, 45, 45, 90 is one of the special triangles. Okay, and the sides are 1, 1 and root 2. So sine 45, opposite over hypotenuse root 2, or cosine 45, adjacent over hypotenuse 1 over root 2. Tangent 45, opposite over adjacent 1 over 1 is 1, right? They have to be in your memory. Instead of memorizing the ratios, you should try to memorize the triangles. Okay, so now same triangle as you see, but instead of degrees now we have the radians, but same information. So again, pi is 180, pi over 2 is 90, pi over 4 is 45. So pi over 4, and this angle is pi over 2, 90 degree. But as you see, the ratios are the same. So if we want to write sine pi over 4, okay, opposite, let's say we are working with this angle, opposite over hypotenuse 1 over root 2. Cosine pi over 4, adjacent over hypotenuse, again 1 over root 2, or if you rationalize the denominator you get root 2 over 2. So tangent pi over 4, opposite over adjacent, which is 1. So again, last year you learned another triangle which includes 30 degree, 60 degree and 90 degree. Okay, and these were the ratios, right? So opposite the 60 degree you have root 3, and opposite the 30 degree you have 1, and the hypotenuse is 2. If you're having hard time to memorize that, remember that. So you can look at a triangle, equilateral triangle. All sides are 2, let's say. Okay, you drop a perpendicular line. So again, for equilateral triangle, all the angles are 60 degree. So this is also 60 degree, but now I drop a perpendicular line. So this is now 30 degree and 30 degree. Okay, then this perpendicular line will bisect this side, so these two are equal, then you get 1 and 1. Okay, and using the Pythagoras you get root 3 here. That is where this triangle is coming from. Okay, so based on that, sine pi over 3, is, so we are here, or 60 degree. Opposite over hypotenuse, root 3 over 2. Cosine pi over 3, adjacent 1 over 2, tangent pi over 3, root 3 over 1, which is root 3. Sine pi over 6, here, 1 over 2. So this is sine 30, same as sine 30. Cosine 30 or cosine pi over 6, you have root 3 over 2, tangent pi over 6, 1 over root 3, using the triangle.